Hello, and welcome back on our discussion of collections. Once again, we are looking at this idea of collections. Our collection is our top interface here. We looked in our earlier examples as we worked with lists and worked with array lists, and we worked with sets and worked with hash sets. We're going to look at a couple more examples here in our second video, so that you can see that in these various data structures, they all have similarities, but they all have unique characteristics that you would choose among the different types based on the problem you're trying to solve, whether or not you can have duplicate items, whether or not you need an ordered set, things like that, or an ordered list. Things like that would go into play as you decide which type of item you would want to implement as your data structure in your program. So we're going to look at example 04. This is a hash map example. Now our last example we looked at briefly was this hash set. Now notice a hash set, all you do is add the item itself, and it acts as its own key, so to speak. In a hash map, what we do is we add an item and a key as well. So this is the data I'm trying to solve, and this is the key. Notice that since again this is a set type of a situation, it will not allow duplicates. And I've manipulated the data in this example so that we will see that we have some similarities, but also some items we're using the same key twice. And notice that we use the same key twice. When I put this first time, spot 3 will say tiger, but when I implement or when I activate this line of code in my demonstration, we'll find out that it will in fact overwrite the tiger entry and make it tigers, because what it does is it matches this key with the entry. So this is what's known as a hash map. Notice I have two base types, an integer and a string, an integer and a string. And that is, of course, how I'm using this put command. I'm not using an add command, but I'm using the hash map command put. We will then try to look at our data. So once again, we're going to use this while loop. We created an iterator. As we saw in our earlier example, we can create an iterator. We set it equal to our set iterator. In other words, it points to the beginning of the list. And what it will do is it will get the key and the value for each of our items and print it back for us. This line here will demonstrate how we can get any particular item by placing its key in there. I can also remove any item by placing its key in there. So I'm going to get one item and I'm going to remove the same one. You can see I've hard-coded this, but there's no reason those can't be variables or user input or any other valid key. Then we'll see our map once again after we remove those items. So let's just run the program and see how this is going to work. So this is my set again. Notice the set is not in the same order that I put them in. I put 12 in Arnold, 2 in Jack, 7 in Calvin, but it came out in a totally different order. Remember, they have their own logic, so to speak, as to the order you're going to get these items in when you use these hash tables. Notice that I said here we have Jack at key 2. I went and retrieved that, and it says the index at 2 is Jack. The value at index 2 is Jack. Remember, we removed item 2. Notice now that I have no item 2 that is Jack. Now notice that also that all my keys are unique. My data doesn't have to be. In other words, my as long as my key is unique, the value can be repeated. And as I said earlier, when I repeat a key and try to put something where something already is, it won't give you an error message. What it, in effect it does is overwrite that entry. Notice here it says my key value is 3 and the value is tiger. But here I'm going to overwrite that. Notice when I run this program this time now, we'll see a slightly different result. And now we'll see key 3 is tigers. Value 4 is still tiger, but key 3 has been changed to tiger. It just changed your value based on the key you provided it. And of course that happened right here in these sets of code here. This is where I identified item 2, and this is where I removed it. This again, both of these while loops are just iterations through that hash table. What I do here, while the iterator has a next, remember that's pointing to my list, I'm going to create a new map entry that I'm going to call map entry, and I'm going to get the next item at the iterator. I'm going to then say the key is mapEntry.getKey, and the value is the mapEntry.getValue, or the M entry. So that's a good look at a hash map. A hash map takes 2 elements. A hash set only 1. The value, it acts as its own key. In a hash map, you give it a key and a value. They're 2 separate things. Our next example here is called a stack. A stack is what's known as a last in, first out data structure. In other words, as I put things in and try to remove them, I'm going to kind of remove them from the back of the list, if you will. I'm going to remove the last thing I put in. You remove them in reverse order. It's called LIFO, last in, first out. So let's see what a stack looks like. We're going to import the Java utility stack. We will create a new stack, and when we add things to stacks, we're going to push them. We're said to push things onto a stack, and we're going to push Washington, Lincoln, and Roosevelt, and then we pop things off. We pop the top is one way to remember it. The last in, first out. We're going to remove the object that we just put in. In other words, we'll remove Roosevelt. Then we'll display that stack once again, and we can easily display this stack using the toString, and it will print out all the elements in my current stack. I then will just push a new item onto the stack. Whoops. And then I'll view my stack once again. Let's see what happens. So here's my, well, you know what, I never demonstrated here. I just realized that. Hold on a second. I never printed my stack before I popped my top. So let me add this here. Here we go. So now I'm going to the current stack. We'll say this is the original stack. How's that? There we go. Now let's run this one more time. So there's my original stack, Washington, Lincoln, Roosevelt. I popped the last item, Roosevelt. My current stack after the pop is Washington and Lincoln. My current stack after I pushed that gem is now Washington, Lincoln, gem. So this stack, unlike our sets, our hash map and our hash set, is an ordered list, so to speak. I use that term list very loosely. But it is an ordered data structure. The order you put them in retains that order, and you pull them out in that reverse order. And that is a stack. And you've seen stack traces on your programs when things ab-end. It just gives you a list of the items that were executed, either pushed on and then popped off that stack to be executed. Our last example here in this section will be various ways we can iterate through a hash set. So we'll import a hash set and a hash iterator. We'll just create a nice little hash set, health, love, and money. similar to our previous example. We'll create an iterator. There's our string iterator set equal to our set, our hash set that we created, this S. While we have another one, we'll just print out our hash set. We'll remove an item, and then we will print through the set again. Notice now, when we remove that, we use the iterator to remove the last item. And what happens is the iterator keeps going until there's no more items left in your set. And it is set itself at the last entry, because after this while loop, the iterator no longer has a next, but like I say, it's a pointer, so it's still pointing to what it was pointing to before. So we'll remove that last item, which will be the word money, and then we'll have to reset our iterator. If I don't reset our iterator, and I'll demonstrate this for you, we'll see what happens. But I reset my iterator to the beginning of my list again, and then I step through it. Let's see what this is going to look like. Here we go. So my set contains love, money, and health. I removed that last item because that's where the iterator is pointing, and now it says the set now contains love and money. Notice, if I don't reset my iterator like this, that again is resetting the iterator. Now notice it won't print my set the second time. The set contains love, money, health. The set now contains end of program. Well, the reason it didn't print it is because we told it to print it while I has a next. But if we don't reset our iterator, then it will never, I will not have a next, so this while loop will never get executed. Another item, you can see how this works, is notice I've reset my iterator here. We're back to a working version now, by the way, where it will print out what we want. The set contains love, money, health. The set now contains love and money, end of program. But now let's say I do this instead. I reset my iterator, and now I'm going to remove another item. Let's see what it's going to remove this time. This time it says the set now contains, well, the problem was I have an illegal statement, because what happened was I removed the very top of my hash map, and now I have an unknown source. It can't find what's left. That's the problem. So by removing that first element, which is what I did, I in effect lost track of where my list was. Now I could also do this. I could say I remove, let me just do a copy paste here. I remove I dot, well, let's use the dot operator just for fun. And what we want to do here is, on our iterator, is I dot next, and let's see what that will do for us. Well, you know what? That's not going to work. So forget what I was saying there. I can't demonstrate that without going into some gymnastics. So we'll just leave this in its more simplified form, showing how we can remove that last item in that list, and we won't work on other removals at this point. We'll keep it on the simple side. So that now gives you an array list we looked at. It gives you some sets and stacks as well. So I hope that gives you a little bit more insight into this chapter we're currently working on, this idea of collections. And really, as I said earlier, you're going to pick your structure based on the problem you're trying to solve. And every situation is unique, and you'll have to reevaluate it each time. We're trying to give you an overview into these various structures you can use. So, thanks for watching once again, and I hope you have a great day, and I hope everything's going well for you.